Hello, and thanks for listening in. My name is Dr. Neville Swade. I'm the director of the Access Program, which is a program of the NRF and the Department of Science and Innovation, and which is hosted by the CSIR. And for this short presentation, I'm just going to orientate you around the kind of research that we are doing. And I'm going to focus in here on weather and climate extreme events. And this slide you're looking at is in fact the report of the IPCC, the Intergovernmental Panel on Climate Change, technical report from late last year, chapter 11, dealing specifically with this, and I recommend this for further reading. The reason I want to tell you this is because this is a good starting point to show to you that this is a really serious manifestation of climate change, and something which we are probably all familiar with. You can look at the IPCC report, or you can look at your newspapers. These are just some symbols and some images of extreme events that have happened in this year, in 2022, all around the world, including in South Africa. We obviously record recently the KZN floods, but there have been plenty of others in South Africa. In the last while, you'll be familiar with the Cape Town drought, the Day Zero drought, the Knysna fires. There was a malaria outbreak. There are droughts, persistent droughts in the Eastern Cape, heat waves, and various other phenomena, fires, for example, that we are very familiar with in South Africa. But this is obviously a global phenomenon. What's important to understand is that extreme events are not unnatural. It's really the frequency and intensity of these extreme events that really matters here. The IPCC report goes on further just to illustrate the point that we are effectively in a new climate from pre-industrial times, the blue being the pre-industrial times. Here you can see the curve. And as things get hotter, so we get a particular response, the likelihood of an extreme event happening. But in the new climate, even under the same temperatures, we have a much higher probability of having an extreme event, and a much higher, even at the events themselves are generally much more intense. And the IPCC has gone on to analyze this kind of regionally. This represents the world map, in a sense, and this is dealing with hot extremes, and we see that we are seeing increases in hot extremes in Southern Africa. We are seeing increases in heavy precipitation events in Southern Africa. Obviously, these are not equally distributed within Southern Africa, but still the region as a whole is experiencing increased heavy precipitation. And in fact, we are seeing increases in drought events. These are also complex in design. And so these are real manifestations that have been observed of climate change impact. And what I want to demonstrate to you is why extreme events are so important as a phenomenon in climate change. So in this, from a paper published in 2018, is a conceptual idea. So what you're looking at here, this green line, represents the normal seasonal fluctuation of climate and weather. Some winters and summers are different from other winters and summers. There's some noise in the signal, but we know that there's a fairly regular seasonal signal, and that we understand quite well. If we add to that the fact that we do have, as I said, naturally periodic extreme events that occur with some periodicity and some intensity. So every now and again, we have an extreme event, which is, as I say, something we can expect. But we add to that a changing baseline, which means that the average temperature or the baseline rainfall patterns, those are trending upwards. And so if we add these three together, what we get is this black line at the bottom. And what this black line shows, just going to move this out of the way, black line shows is a combination of those three signals: the seasonal signal, the trend, and the extreme events. And under these circumstances, these extreme events take us into new territory. So we see records breaking. And there are two types of events. There are those from which you can recover. So if they happen to be at a certain level that they are not that destructive, they become disruptive or survivable. But if they happen too frequently and there isn't enough time to recover, or they happen with too much of an extreme signal, then we get into terminal or extinction extremes. And these are the things that we are concerned about. So to drive this point home, one more theoretical slide for you. Before I do that, I've got some information which is just hot off the press from some modeling done at Wits University by Professor Francois Engelbrecht and his group. And they are doing some local modeling with the local model and use the scenarios that are produced by the IPCC. There's the worst case scenario, business as usual 8.5, and then various other mitigation scenarios. And under those circumstances, these models predict our future. So we've looked at observations, what the IPCC has reported. Now we look at the future. And there we have these different scenarios of 1.5 degrees of global warming, 2 degrees, 3, 4, etc. And this predicts what will happen to the Earth's surface temperature. And using those scenarios, we look at Southern Africa. And here again, at these different scenarios, we see what happens in Southern Africa. And what it shows is that Southern Africa is warming faster than the rate of the global average. And that's very, very important to understand. And it shows us where how that warming is distributed under these different scenarios. Similarly, if we look at the number of heat wave days, we can see how these are increasing from less to more, with more being 50, and we can see how these are predicted to change over time under these different scenarios. And so we know now what it means in the past and what we can observe, and we now know about the future. So let's just consider what this means. So at its top graph, you'll see again an idealized seasonal signal, winter and summer. And what we have on the red thresholds is effectively our ability to manage what is normal or what is traditional in terms of the extremes of our typical climate. And so we adapted to that. We build in a certain way. We are adapted in a particular way. But if you live in a disadvantaged circumstances, such as in an informal settlement, your ability to cope with even those traditional average extremes is already compromised. If we look at the middle panel, there we impose extreme events. This is when occasionally we exceed that level of tolerance that we are accustomed to, that we are built for. And often what happens is we build in harm's way. We put things where we have forgotten that extreme events can reach. So certain areas we build in which are dangerous. And again, particularly poor people are often forced to live in areas which are generally more vulnerable because they are less developed. And so those are opportunities for habitation, for example. And so we see exceeding of those levels of tolerance. And that's when we start to see damage, as we did in KZN, for example. But added to that is the fact that our resilience is also dropping. So at the bottom panel, we've got these converging lines. Really what that means is not only are we exceeding those traditional levels of thresholds, but our ability to cope with what was traditional is reduced because we are much more vulnerable for a variety of reasons, both socio-ecological as well as geographical, historical, and even in terms of management. So if we're allowing people to build in a floodplain, their resilience to extreme events is much reduced. And so when we look at this and we look at the average doesn't really tell us much about the variation, doesn't tell us much about the trends. And so it's really important to look at the changing seasons. What's happening to our seasons? Are we getting more extreme seasons? Is our baseline changing? And does that mean more frequent extreme events? Or is there a trend where we're seeing, for example, warmer winters and hotter summers? And what is the implication of that to a variety of different sectors? And then we also get more complex patterns where we see decadal or even shorter-term trends, interannual trends, and longer-term trends, and combinations of those two. All right, let's try and do that. We've put up. This poster is about some particular research we're doing, which is funded by the Belmont Forum, and it's looking at extreme events in the Benguela ecosystem. So for those that don't know, the Benguela ecosystem is the ecosystem that runs along the southern west coast of Southern Africa. It includes of the west coast of South Africa, all of the coast of Namibia, and the southern part of the Angolan coastline, where it becomes a different system. And this is characterized by upwelling. It's one of the most productive ecosystems in the world. It's the second most productive marine ecosystem in the world, and it supports all of the activities that we are familiar with, such as the industrial scale fisheries and various other very important maritime economic activities and livelihoods. And what this project is really asking is, how are extreme events trending? And in particular, how are people who are living in the Benguela events? I have one example of that in a moment, which I'll give you. But it's really important to understand, not just from a scientific point of view, but from the point of view of people who live and work in these systems, how exactly are trends in climate, changes to climate variability, and this includes ocean climate, how are these, and then the extreme events, how are these affecting their operations? And this is what the study does, and we have a whole variety of different case studies in Angola, Namibia, and South Africa, working with partners in Norway and the United States on this project. So I invite you to read that poster, which is on the wall, and there's also a takeaway pamphlet which has the same information. And then, as an example of this, and also a project which is from another program funded by the NRF that we're having, this is really looking at one example where we know that extreme winds in the port of Cape Town is causing disruption. That graph gives you an idea of how serious the problem is. 24/7, very important port, 24/7 operating port. Cape Town, our third biggest port. And what's been experienced is extreme winds to the extent that the port has to close for several days at a time on occasions. And this causes huge operational slowdowns. And we're looking at the fruit industry in particular, because the fruit industry is very time sensitive. And so exports of fruit, which are now sitting in a container at the dockside, waiting for a container ship to dock in order to export the fruit, is really critical. Sometimes those ships don't wait because there's too much of a queue or a backlog, and then they have to transport it by road to another port to meet the container vessel. And so this is a really serious problem, and the solution that we're looking for is to really understand these winds and the trends in these winds from a climatological point of view, to be able to understand what types of climate arrangements or configurations result in these disruptive winds, and what the trend is currently and what the projection is in the future. We're also looking at the economic impacts of this to understand what it's costing the economy, in order to justify any potential engineering solutions, which is our third project, which is to look at ways in which we can operationally anticipate the wind with an early warning system and manage it so that there is as little disruption in the port as follows. And then the third poster I invite you to have a look at is really to think about what the impacts of these extreme events and climate change variation and trends are on health. And this again just iterates that we know things are changing from a heat wave point of view. We know things are going to get hotter. Excuse me. But what we're seeking to do here is to understand in general what are the direct impacts, such as people drowning or getting caught in fires or suffering the consequences of droughts, to the indirect effects on various diseases, such as malaria and diarrhea, for example, which are very important diseases. These are all climate-sensitive diseases. And so what we're developing are several solutions to understand these impacts, to understand the relationship between climate and particular conditions, climate-sensitive conditions, and then to forge collaboration amongst climatologists, medical practitioners, public health authorities, and the private sector, such as health insurance, and to develop new modeling and early warning systems. We have three programs here. One is CliMed, which is a Japanese collaboration, IDUs, which also emanated from a Japanese collaboration, and now we are developing a national and potentially regional research alliance for climate and health. So thank you very much for your attention. I want to point out that we have a range of partners both in the country, in the region, And internationally, some of our partners are illustrated here, and we need to acknowledge that Access works as a series of consortia, and we depend very much on our partnerships, and really our role is to create these partnerships for these various research projects and applications. So I invite you to have a look at the posters, to meet with some of our students, and to learn about our Habitable Planet program, which is a capacity building sub-program of the Access program. So, thanks and enjoy the conference.